Ladies and gentlemen, this is Joe's Classic Video Games back with another cool jukebox repair video for you today. We have been working on this rock-ola 490 jukebox, and it's the Super Sound 2, so this is the 490-2, I believe. We've done a bunch of videos on these in the past, and people seem to enjoy them because there's not a ton of information out there about this particular model box, and it kind of gets a bad rep because it had this control unit in it, the System 2 control unit. It was only used in, I think, the 490, the 494, something like that, just a couple boxes. And then by the time they got to the 498 or something like that, they moved on to another control unit. But they sold a ton of these things, and a lot of them are broken. So I wanted to show you a little issue that's going on with this one, and we're going to attempt to repair it. We get a lot of people emailing us and asking us questions about these and calling us because they've got one they're trying to work on. So I'm going to show you kind of what one's doing and what we think might be the problem and what you can look at on yours and how you might get it working. So this particular one, when I plug it in, just give you an idea of what to look for and what's going on. If I try to scan it, I don't get any kind of scan action. I do get the turntable moving, which is something that tells you something. Okay, we're going to slide this back to off. Okay, and if I go to operate, it should be trying to go back to home position, and it's not. The turntable's barely trying to move. There's some stuff going on, right? So let me show you what to do if you end up with one in a similar situation. Okay, the first thing you want to check is to see if all of your LEDs are on the power supply. So if you've got an earlier model of the 490, it will have a slightly different power supply in it. This particular one is the 54920-A. And the reason that it's in this one is because, like I said, it's the 490-2. So there is a 490, a rock-ola 490-1, and a rock-ola 490-2. They sold so many of them that they redesigned the entire power supply kind of right in the middle of the run. Okay? So this one is the one that's in the later models. So you want to see, but if you've got the earlier one, I believe it has a more horizontal thing up here. This is the amplifier, but it has a power distribution center that has a little board on it with the LEDs on it. So you want to make sure all the LEDs are on. If one of them is off, that's probably your issue. Now, if one of them is off, it's possible that it actually works and the LED is just burnt out. But that's I'm just giving you a place to look, right? If you search the internet for the schematics for a rock-ola 490, they are out there. You can download them for free. If it's the 490-1 or the 490-2, like this one. If it's the original 490, I can't find those schematics. So if somebody has some, scan them and mail them to me. But there is the rock-ola 484 schematics, which is from a year or two before this, that has that older style power supply in it. Those schematics are floating around. So depending on which one you got, you need to kind of look and see if it lines up, right? So you're going to have to get your hands dirty a little bit to work on these, though. Okay, so you want to see if all of those power lights are on. However, there are a couple more voltages that come out of this thing that they don't have an LED for. So it could be that these four are working, but you have a couple more that are missing. I'll show you that on the schematics here in a minute. So you want to see if that's working. You want to look at your board up here. Without that working, your System 2 control unit working, the turntable and all of this will never scan. Okay? So I can't put this on right now because of our battery setup. Basically, we're not going to deal with this in this video because this system here is actually working. We're going to deal with the power supply and the mech board. Okay, but basically, if you look up at the top, it tells you what those lights mean. The left light means standard pricing, special bonus pricing, lock-in pricing, default pricing, and then there's one that says normal operation. Okay, now when I turn this thing on, if I can get focus back, I'm going to turn it off and back on and watch what the light does. Or I'm going to try to, without knocking the power brick out of the machine. Alright. We're just watching the light, people. See the one at the bottom right? And then see how it went off? Okay. Let me get my focus right. So when you first apply power to it, it's saying initializing, lock in, that light is on. And this light is on over here where it says standard pricing. Okay? And so those stay on. And then after a few seconds, they both turn off. And on ours, this one comes on where it says default pricing. Yours may come over to normal operation. The reason that ours doesn't go to normal operation is because we don't have a battery installed. So we haven't saved the pricing in it to the point where it can move over to that. But by the act of it turning this light off, turning that light off, and then turning that light on, what that tells you is that the board is actually working. It may not be working fully, but it's at least running the code and it's booting up. So if yours isn't doing that, and this light's staying on, or that light's staying on, you've got a problem with your control unit. If you've got a problem with your control unit, you might be in trouble because you're going to have to fix it yourself, basically. There's nobody around that repairs them that I'm aware of. There may be somebody, but not that I'm aware of. Luckily, all of the chips on that board are socketed. There's a front board and a back board. If you've got a couple of them, you might be able to swap the boards around and see. You could order a new chip for every board, every chip on it if you wanted. You know, you have to deal with that. But we're not going to get into that too much in this video because I actually have a working one in there. I also have a working power supply. But, as you can see with the working board and the working power supply, I can't get the basket to turn. Right? We're stuck on a record. We're at record 190 or something like that. Okay? So what's going on? I get people emailing me about this constantly. Constantly. Okay, let me show you the first thing that you need to check. Alright? There are two motors that do two different things, or three motors actually, on this setup, right? Now, rock-ola's setup didn't change much over the years. It's very similar no matter which rock-ola you have, but this is specifically for a rock-ola 490 or a 494. This is the cam, okay? So this unit spins whenever this is improper, whenever it's working properly. All right? So there is a switch, or four switches here, that change state depending on where this cam is, right? And when this cam turns, it turns the gears and makes the arm move and all that crap, right? Makes the gripper arm function. All right? It can only be in one of two states. It can be where the mechanism board is trying to control the gripper arm, which is in charge of grabbing a record, spinning it around and laying it on the turntable, and then picking the record back up, spinning it around and laying it back in the basket. It can do that, or it can move the basket, right? It can't do both because if it could, you'd break all the records. So let's say that it's coming down and the record, and then the basket starts moving. Well, it would break the record, right? Or it would put it in the wrong spot because the basket moved while it had the record here. So basically, there is a motor that turns the basket around to the correct spot. Once it gets to the correct spot, it stops, and then, and only then, it allows the gripper arm to grab the record and set it on the record player. Once the gripper arm starts moving, what happens is this little switch right here on the top, this one, which is switch number 1, they call it. There is a little groove down in there that switch has fallen into to allow it to open. See how the roller is down in a hole there? Let me brighten it up a little bit so you can see it even better. I'm trying to be as thorough as I can on several of these videos so people can see what to check on theirs. See how that roller is down in that hole? If you're not like that, the basket can't turn because it thinks that the gripper arm is up. So what happens is when the gripper arm starts turning up, this cam turns. And when it does, it closes that switch. Once that switch closes, the basket can't turn anymore. That's part of what turns off the power to the basket. So your basket will never turn when you put it in scan or operate if that switch is not open. You have to be in that hole. Okay? And similarly, your gripper arm will never work unless you're in that hole. Or I'm sorry, disregard that. We're just talking about the basket because that actually changes state as that turns. Okay, so there are two voltages that the power supply puts out that there is not an LED for. You wouldn't think there would be. Okay, well, one of the voltages is this turntable. So watch when I put it in scan, the turntable starts moving. I'm going to show you why that is here in a second. There's a third motor that only runs the turntable, and it runs off of 120 volts. It plugs in right here where it says 120 volt AC turntable power. Now the two gripper motors are ran by 28 volts DC, and they're ran, I think it's 26 volts, 26 or 28 volts, and they're ran through this mechanism board. That turntable is ran straight out of the power supply. So how do they turn it on and off? Well, the CPU is doing that. So if you don't have this CPU in there, you can't get that to do that. Okay? Let's test that theory, shall we? Let me turn it off and unplug the CPU, and let's see if the turntable will turn without the CPU plugged in. Make sure I'm telling you the right information. Okay. The machine is off. We're going to unplug these two connectors on the top, which are the power and the signals coming out. I'm leaving this plugged in. It's just telling the display what to do. Now let's see if the turntable will work with that unplugged. So we have the board unplugged. Turntable's not on. It's trying to turn a little bit. That's some kind of capacitor thing. But as you can see, it's not able to do anything without that plugged in. Okay, that's because the power supply the CPU actually tells the power supply to turn on the turntable. What I've figured out is that the CPU also tells the power supply to turn on the motors that run the basket. So a lot of times whenever people email and call and say that their basket doesn't move, they think it's the motor. It's hardly ever the motor. If you've got this problem, your motor's probably fine. So I'm going to show you in the schematics exactly what's going on. Okay, so this is a little bit of the rock-ola 490 schematics. Now we are looking at the CPU section of that control unit. So the control unit is running some things. I have a plush crane in the background making a bunch of noise. So anyway, this is on the control unit, that box up in the front. If yours is working properly, it's probably doing this, okay? So one of the things that it can do is it can send out and receive all these little signals here. So one of the signals that it sends out is this run signal with a line over it. Usually when there's a line over something, it means that it's active when low. So if that line there goes low, then that run signal, as they call it, is active, right? So you can see that the board has its way of doing it, and it has a LS174 here, and that connects to a couple things, an LS32E3, and it runs through a couple more things, and it's gated with different signals and stuff, and it comes down here and it turns on, it has another thing here, it turns on a transistor and blah, 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 but whatever, it can make that run line go low, okay? So if it were to do that, that would be a low signal, right, that it's sending out. Now I'm going to show you on the power supply what it uses that for. Okay, so here is further up the schematics. They call this the rectifier PCB assembly, which is part of the power distribution assembly. So this is that big box, the power supply we were looking at. Now, just to orient you, orientate you. Here are the LEDs that we saw that come on whenever the power is working, right? So there's two there. So if this light is on, it is the 24 volts AC light, okay? If this light is on, it is the 26 volt DC light. If this light is on, that means the negative 28 volts DC is working. And if that one is on, it means the 5.7 volts is working. So if you've got those four LEDs, then you've got most of the voltages, but there's two more voltages that they don't mention. There's no LED for. So one of them is this. Look, switched 120 volts. So switched means they can turn it on and off. And look, it goes to the turntable. So our turntable, did you see how it turns on and off depending on where that switch is? Right? So how are they turning that on and off? The turntable, by the way, just plugs right into there. Okay? How are they turning that on and off? With this little baby. Look at this thing. This is a H11C3 optocoupler, photo optocoupler. Now, why in the world are they using that? It's because the way these things work, this is a little chip inside of the power supply. Basically, there is a like an LED inside of the thing, or I think it's an LED. That basically, when you turn it on, when you turn on that LED, there is a little receiver inside of it that can tell when the LED's on, and when it's on, it turns on this connection. Now, why do they go through all that trouble? It's because they want to be able to control 120 volts AC, which is some juice, with just a little tiny trickle signal over here on the other side. If they were to, they would need a straight up relay that'll switch 120 volts AC. The thing would burn up, and it has the potential to short the other things. So that this is just an easy way to do it, right? So, how does this optocoupler work? Well, it's getting power straight from one of the, like it's a 12 volt line. It runs it through a resistor. It says it's 1.2 volts DC on this one side, and then what turns on the other side? So the LED, for it to turn on, it's literally a light inside of it. For it to turn on, this side has to be connected too. This side is permanently connected to 12 volts through this 1K resistor. Well, what turns this side on? It's our run signal that we were just looking at from the PC. I mean the logic unit, control unit 2, logic 2, system 2 logic unit. Right? So why is that important? It's because since the turntable is turning off and on depending on where the switch is, we know that run line's working. So here's the schematic of the turntable motor, which we're turning on and off, on and off, on and off. And the only way we're able to do that is if the switched 120 is turned on and off, and the only way that can happen is if that optocoupler is turned on and off, which means that the only way that could be happening is if our run line is being used. So we know that's working because the turntable's turning on and off. Now, why am I showing you this? It's so you can check it on yours, right? Leave your CPU plugged in and see if you can turn the turntable on and off by moving to scan, scan, operate, off, whatever. See if that turns on and off. If it does, then you know at least that line is running. If the CPU is not running on the in that logic unit, though, that you're not going to be able to get that to work. Okay, so then what else does that run line do? Well, here's the interesting one. So that run line connects to that, and then it also connects through this resistor, a 1K resistor, right, down to here. Boom, right there to that capacitor, which is across this coil, which is a relay in the power supply. Okay? So if that is not connected, then this relay is not pulled in. All right, one side of the relay is connected to 45 volts. Okay? So 45 volts is coming from over here, the transformer. right? So one side of the relay is always connected to 45 volts, but the other side doesn't have a connection unless that line goes low. All right. So why is that? It's so that same run signal can turn this relay on and off. So what does the relay do? Well, if the relay isn't pulled in, then you have a normally connected situation here where this line, which is the ground from the transformer, the center tap from the transformer, connects to this 24 volt DC line here and basically shorts it out. So why does it do that? Right? I may have it backwards of what it does when it's on or off or whatever, but basically it connects to there and shorts this to ground. Well, what that does is it makes this, the input to this LM317, it's getting 45 volts on one side, it's getting ground here, and it's basically turning on and off the switched 26 volts, not to be confused with the 26 volts. There's two different outputs. So there's a 26 volt and a switched 26 volt. So there's no LED on the switched 26 volt. Now I know this is really confusing. This switched 26 volt is, are you ready for it? It's how it turns on and off the gripper motor and the mechanism motor. So we know that signal works, right? Where are we? We know that signal works down here to turn on the relay. But it's either not turning off the relay or not turning on the relay or something. Something's not right. And that's why you're not getting this voltage out. If you check this switched 26 volts, which is a red and blue line coming out of the power supply, and it goes over to the that switch we were talking about on the cam on the front of the machine. If you check on that red and blue line, I'll bet you don't have 26 volts there, and that's why you are not getting your motors turning. So a lot of people think, I think my motor's bad, and they buy new motors. Those motors don't usually go bad. They're like the last thing to go bad. It's much more likely that some of this crap's going to go bad. So you know what usually goes bad? That relay. So look how they've designed it. If the relay is closed, you have just shorted this to ground. So this 24 volts isn't there because now there's ground on both sides of this Zener diode here. 24 volt diode. So it basically takes it out of the equation. If that's open, now you've got the Zener diode in play, and it raises this up to 24 volts because it's basically using the output of the voltage regulator there and all this. It's an adjustable voltage regulator, right? So if this little relay is bad, that's going to cause you all kinds of problems. That's what's wrong with mine, I believe. So here's the next. Okay, so if that does pull in, it can also send ground to this connection. So what does it do? Well, if you look on the schematics, see the line going up there? It connects up to here, which it calls audio control. So it says audio system socket. It's probably something that turns on or mutes the jukebox, or turns on the jukebox. Not the jukebox, the amplifier. Right? So why would they do that? Well, once the gripper arm is doing its thing, and it's in this position where it's supposed to be or whatever, maybe, I'm just guessing, maybe the control unit turns off the motors, the power to the gripper arm, and the power to the basket, and turns on the power to the output of the amplifier. That's why it's all muted until the record starts playing, and then you hear it pop on. That's what I think. That's probably how they're doing it. Okay, so all of that to say, if that's some things to check and the order to check them in to try to tell what's wrong with yours, right? So if you don't understand exactly what I was saying, go back and watch through the video and maybe you'll catch what I'm talking about. You want to check your power supply, you want to check the lights on your logic control unit. You want to check to see if the turntable turns and turns off, which is also important, right? Because that will tell you if this run line is working. And then finally, you want to check the output, this voltage here, and see if your switched 26 volts is going out on the red and blue line coming out of the power supply. If that never comes on, then of course your motors aren't running because you don't have the voltage for them to run. So let me show you what the mechanism board does with that voltage. So the power cable comes down here and it plugs into that board in the front I was talking about, which is the mechanism power board. Okay. Now, depending on which version of the machine you have, that thing may actually be on the back, but it'll say mechanism power board right on it, right? There's a couple different designs, like I said. And there's a little 6-pin connector that plugs in, okay? And so one of them is a signal that's called cam 1. I think that may be actually a signal back to the board. There's a home switch signal here. Now that's basically so it can tell when it gets back to the home position. There is an A and B, and then look, here's our 29, they're calling it 29 volts at this point, 29 volts DC switched. It's that same red and blue wire, and it plugs in at pin 5, right? So if you look on here, pin 5 on the actual board, comes down, and it goes all around, and it comes up here, and boom, it goes to the fuse. So if that fuse is blown, of course the board can't use any of the power, but that's how the power gets on the board. The way they turn off the motors is they can be completely turned off by the power supply, which is turned off by the CPU. Now I was just thinking, since they use the same line to make the turntable turn on, they can't turn off the motor, the power to the motors if they have the turntable turned on, right? Maybe the turntable has another way of getting power or something. Okay, and then there's a few switches, I'll show you too, on that cam that can turn things on and off. Okay, so we finally made it to the motors, the magazine motor and the gripper motor. So you see, like if we're looking at the magazine motor, so I can't get it to turn right now. One side of it and the gripper motor is connected to a red and white wire, which comes off of the mech board, right? And then the other side, the magazine motor gets its power through the pink and blue wire that is connected through that switch number 1 that I was talking about, right? So this switch, if it's down in that hole, the basket can get power, the magazine motor as they call it. And then if it's out of that hole, it connects back this way, which sends the power up this way to pin 5, blah, 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 and does some other tricky stuff, right? So that's what you need to look at. So I'm interested now in how when it would turn off the magazine power. I guess it would just turn it off whenever it's also going to turn off the turntable. Yeah, so there must still be voltage on that line. Oh yeah, it has to be. So there has to still be voltage to the mech board while the turntable's turning, because it still needs to be ready to hang up reverse the everything and hang it all back up, run the motors in reverse and all of that. So the actual gripper motor goes both ways. It has to lay it down and then it has to pick it back up again too and put it back in the basket. So it has to run either way. So they have a little setup down here where they make it go backwards. How does that work? Pin 7. A reverse relay, it seems to. Reroute some of the signals to make the power go to one side or the other. All right, so anyway, all that to say, I think that relay's bad on my power board. So I've ordered one, but guess what? You can't get the one that's on the actual power supply. They're obsolete. Apparently this is a problem that people are running into in all kinds of vintage audio equipment where they use these little relays that you can't get anymore. And so the footprint's different, everything on it's different. So I've ordered a substitute. We're going to rig it up in the best possible way. We'll consider it an upgrade. But we have to replace that, and we'll see if that gets us up and running. So I'll show you what that little board looks like on the bench. Let's check it out. Okay, folks, so I've got the power supply out of it. Okay, this is the board that we're looking at on the schematics. There's a few capacitors in there I want to replace. Someone will order those too. All of the fuses are fine. And I've got it set up. Now be careful if you're messing with this, folks. Don't do this. Now, if you decide to do it, you did it against my wishes. So the thing is, you can plug this in just outside of the machine, right? And then check your voltages and things from there. So if I plug it in and turn it on, I've got all 4 of my lights on, right? Now those lights, by the way, that doesn't necessarily mean that the voltage is perfect. It just means that there's some kind of voltage there. Okay. Now, this is the relay that I'm talking about. This is I'm going to turn the camera instead of turning the machine. It is a Potter Brumfield R50-E2-Y1-24 volt DC. So that's a 24 volt relay, and it's just a 1 pole. So it just goes from one connection to another. There's a 2 amp. The coil can handle 2 amps, and the 1 amp it can handle 1 amp on the 120 volts that can run through the contacts. That is this area right here. Now again, if you look, the normally connected shorts over 1N4749, which is a little diode, okay? Now with the thing turned off, notice I have replaced that diode. I've been messing with it. I messed with this last night. Then I decided I better film this. With it turned off, that diode is at a direct short across it because that's normally connected. So we need this relay to pull in and move this away from here to here, which will allow this to pull the 24 volts or whatever from the output to make this output properly. Okay. Okay, folks, so we've been ordering all kinds of parts. Not all kinds, just a few. And I have replaced the major capacitors, the bigger capacitors on this little board. But our main problem, we think, is with the relay. So here is the relay. It's an R50-E2-Y1-24 volt DC. This thing's completely obsolete. They haven't made it in forever. You can't get anything that's even similar to it because the footprint is strange. So these 2 outside ones here are the coil, the 24 volt coil. So when 24 volts goes to that, this is the common. It connects to this inside post here. That's the normally open. This outside one is the normally closed. Okay, I'll show you a little drawing of the schematic. So if you can kind of tell what that is, basically, you know, when the coil pulls in, it pulls it from one way to it's connected the other way. Okay, if I don't drop it on the floor. So the coil, if you test the resistance across the coil, it's like 700 ohms, which should be fine, but it isn't working. So it must be, if it pulls in, it's not connecting this pin to this middle pin here. But this pin is connected to the top pin. Okay, so that's the normally closed position. When it pulls in, it should change this pin to this pin. But it's not working. So I Googled this thing, and there are a few of them out there. They're trying to get $200 for this thing used because apparently it's in a lot of vintage audio equipment, which must have been where they got the idea to use it in this jukebox. So I looked around. I said, you know what? I will just order another 24 volt relay, and then I'll just wire it up and it won't be no big deal. So I looked online, made sure to get one with the right specs. So this one is, if you're running 1 amp through it, if you're running 120 volts AC through it, it has 1 amp 1 amp rating on the contacts inside of this. So you can run up to an amp at 125 or 120 volts AC through it. But if you're running 28 volts DC, which is pretty much what we're running, this is like, what, 26 volts DC, you can run up to 2 amps through it, right? So this thing needs to be rated for 2 amps, my replacement one. So I look online and I find one that's rated 2 amps. Looks pretty good. I was like, oh, okay. Let me order that. So I ordered it. It's like $2. I order a couple of them. It comes in. It's this little tiny relay. Right? Look at this thing. So it's an Axicom 1M07. But it's rated for 2 amps at 28 volts, or I think 30 volts DC. It's rated at 2 amps. So it's got the same rating. But look at it compared to the other one. And so I've looked and looked and looked and read and read and read, and I read this data sheet and this data sheet. I think it's the same rating, people. It's just really small. That's not really the best one to use, though, because it's so small that the leads are so close together that it's harder to use, right? But what I did was I very carefully attached wires to it, and then put shrink wrap on the wires so they wouldn't touch each other, soldered the wire to the legs, and then ran the legs down into the board, into the 5 holes that the original relay used, right? So the 2 of them are for the coil, 1 of them's the common, and then the other one is the 2 contacts that switch back and forth. And I got it all wired up, and I got some heat shrink on it, put a little zip tie on it and everything, so it can't short out or anything. It's just kind of sitting there. It's so small, you could zip tie it to something else. This is not really the best one to use. I wish I had a bulkier one, so I may order one that's bulkier, but it is rated the same, so technically it should work. Okay? So how are we going to test it? Well, on the schematics, it's got that run signal illustrated, right? So that run line comes in, and it's basically grounding this up here, which is the optocoupler we were talking about, which turns on the 120 volts. And then also through this resistor, it will turn on our relay, which is this area here, which will turn on our 24 volts. Okay. Which will make our switched 26 work, right? So we're going to try it. Now, I've got the multimeters hooked up on the output of that. Let me turn it on and we'll see what kind of voltage we get. Nothing, but it's all on, right? Now if I ground that run line to where it thinks that the CPU is telling it to turn on the run line, oh, I'm on AC. That won't work. There we go. So I've got 24.85 volts. If I turn the run line off, we have 2.4 volts DC. Okay. So put it back. 24 volts. So it now should be able to turn on and off the motors. Very cool. Okay, folks, we've been doing a lot of work on the machine. We've been working on the the control unit, the amp, the mechanism, the lighting, which was actually a really big problem. We had to put a fluorescent, a more modern ballast in it and take all the old ballasts out and rewire half of the stuff. If you get a problem, by the way, where your computer keeps going back to initialize and it's doing it over and over again, or it sticks over there, if you have a light bulb that's blinking, it'll make it do stuff like that because it's screwing up the voltage that it needs to boot. Okay. But I just wanted to show you, I've got the lid carefully leaned down here. As you can see, we have that new relay in there. All right. So I'm going to show you what this thing is supposed to do when you turn it on. Okay. Just so you'll know if yours isn't doing this. Okay, so it's off. This is what you should get when it comes on. It moved just a little bit. Yours may or may not do that, depending on where it's at, or that may be a capacitor thing or something. So you've got that, and then as it's scanning, the turntable will move because it's using that home line that we were talking about. Now that means that relay is working. Right? Put it back in operate, and then if I pick a record. Now I can't play a record right now, people. But what I'll do is I'll pick up another, I'll do another small video that shows one playing. But as you can see, everything is working. We already had our control board working. So what it ended up being was that relay. And you can see it's up and running in the cabinet. So if you have an issue where you can't get anything to turn at all, it very well could be that line on the power supply. So you kind of need to check that. And kind of a giveaway, well, I don't, you know, the turntable moving, I don't know if it actually needs the relay to work because it's using that optic, actually, that coupler. So, but there you go. I hope that helps you with yours. Check the relay. I believe I've had several that have that relay bad in it. I've had a couple in the past that I swapped the entire power supply out in it. And looking back, I think that's what the issue was. Because you'll get all of your voltages, but if you don't check that switched voltage, because they don't really mention it and they don't have an LED for it, you may not know that. They're blowing me up on the phone, people. So I hope you enjoyed it. We'll upload another video of this thing actually playing just so you can hear what it sounds like. We've got a ton more videos on especially rock-ola jukebox repair. So check those out on our channel here. Make sure to give us a thumbs up for taking the trouble to film it for you. And leave your comments down below. Now, if you want to know how you can support our channel, I may have mentioned it earlier, but there are links to Amazon down below. If you're going to buy anything on Amazon, they may have that relay on there. If you're going to buy anything on Amazon, click our link, and that'll take you to Amazon, and then you can browse around, and anything you buy gives us a tip. So we appreciate everybody that's been doing that. We will see you on the next video.